Hello students, hope you are all well and going good. Welcome you again in my channel. So today we are not going to discuss any theoretical topic, rather I will talk about some problems, and most of them are coming in your GATE exams 2018 to 22. In between that period, these questions you will find in GATE questions paper. So the first question is, here you can see the linear transformations S and T are defined on R3 to R3 like this, and where theta is in 0 to pi by 2. Now what you can recognize from this, the expression of T. The expression of T demonstrates that the linear transformation is simply like a rotation transformation in three-dimensional vector space R3. Now you have to check whether S is 1, 1 or T is 1, 1 or not. So to do that, let's first check whether S 0, 0, 0 is the zero vector or not. Because you know, if dimension of kernel of T or nullity of T is 0, then the transformation T is 1 to 1. So you can check here S, and we see S is 1 to 1. And one more thing, next question you will find, sometimes it is given not 1 to 1, even it will be asked for invertible or not, because the dimension of R3 is finite. So I have mentioned in my lectures, if dimension of a vector space is finite, then 1 to 1 implies onto and vice versa. If dimension of the vector space is finite. Okay? Similarly, you can check for T. If we consider T 0, 0, 0 as 0, 0, 0, you can find the only possibilities is x, y and z are 0. Because from here you can see tan theta is x by y, and here tan theta is minus y by x. This is possible only if x and y both are 0, because your theta lies within 0 less theta less pi by 2. Okay? Now coming back to next one. The question is similar, but see, 1 to 1 is replaced by invertible, just as I have mentioned. So always be careful, if it is asked for invertible and the dimension of the vector space is finite, you will check first the 1 to 1 correspondence. And similarly here you can check whether S and T are 0, 0, 0 or not. Then it is easy. Suppose I consider, I need to check whether this is true or not. Sorry. In that case, x equals to 0, x plus y 0 implies y 0, because you know already x 0, x minus y minus z equals to 0 implies z is 0, because y is 0, x is 0. So there is no vector in R3 such that no non-zero vector such that S of that vector is 0. So nullity of S is 0, and so S is 1, 1. Finite dimensional vector space implies onto, so S is invertible, and your task is to check whether T is invertible or not. This is which year I forget, maybe GATE 2019. I am not sure, you can check it. So what is the question? Let's see. V with a vector space of all 3 by 3 matrices with complex entries. Be careful about this line. Over the real field. So it is like M3 cos 3 C. Complex entries on real field. If W1 is this, what does that mean? This means W1 is a Hermitian matrix. You know this. Hermitian matrix. And W2 is given like trace of A is 0. Now, what is the dimension of a Hermitian matrix? It is n into n plus 1. Here your n is 3. So, dimension of W1 is 12. And dimension of W2 is, since it is a 3 by 3 matrix, so 3 into 3, 9, minus, you have given one condition, trace of A is 0, so minus 1, 8. And also you know that diagonal entries of a Hermitian matrix can never be 0. It always be real or complex. But if it is Q-symmetric matrix, then there is a possibility. In Q-symmetric matrix, the diagonal may be 0 or purely imaginary, but in case of Hermitian, it is real. So W1 intersection W2 is 0, and you know the dimension of W1 plus W2 equals to dimension W1, dimension of W2 plus, sorry, this is not plus, minus dimension of W1 intersection W2. I hope you are getting the